Hey math kids, today we're going to talk about 2.DA, and we are just comparing functions more. This is day 2 of what we're doing. So what we're going to start with is f of x equals 2x plus 3, and we're going to show that on a graph. So all of this would be given to you. So we start at 3, we go up 2 over 1. Okay, so if we're given that on a graph, it's asking us what, change colors, what would f of x plus 3 be? So it doesn't want you to regraph this or anything. It's like, what does this plus 3 do to the graph? Well, if we take a function, we add 3 to it, we actually move up 3, so 1, 2, 3, and then we would create the same slope, just a parallel line that's been moved up 3. So a question like that, that's really all it's asking for. Now, the next one, we start with another graph. Let's do this. And it asks the question, how would we need to transform this? So if we call this g of x, how would we need to transform g of x to make it an odd function? So to make it an odd function, we needed to cross through the origin. So one way we could do that is just move it down 3. So we could say g of x minus 3. And that would go 1, 2, 3. We'd get a parallel line that goes through the origin, and any line that goes through the origin is going to be an odd function. Now another way to get an odd function is if we take g of x and we move it to the left 3. So to move it to the left 3, 1, 2, 3, put us right here. And to do that, we need to do g of x plus 3, because when we're on the inside, we do what's counterintuitive. So the left feels like it should be negative, but it's positive. So if you want to try that out, just start with a line, something like that, and then see what you need to do inside of the parentheses to make it move to the left. So does this need to be a positive value or a negative value? But like I said, this will move it to the left, and so we would get the same line that's graphed right here with the yellow. Okay? Now, another type of question you'll have on your homework. You might start with a function that looks like this, and then another function that looks like this, and that's labeled as k. And it says consider the two graphs shown on the right. The first graph is f of x. Which function is shown in the second graph? So if we call this f of x, we want to relate this. Now, we moved our origin over to k. That's really all that happened in these two functions. And so if we move to the right k, it's counterintuitive, so it's going to be x, x minus k. And so that would be the name of that function if the original one is f of x. Okay, that's essentially it on that one. Okay, another graph. We start with a parabola. it looks like this. And it's given that the graph is y equals x squared. And then we want to graph y equals x minus 4 squared. And so what that's going to do, once again, we feel like it should go to the left, but it doesn't. It actually goes to the right. And so if we just go 1, 2, 3, 4 and graph it, that would be our new function. Okay. And I think for the most part that should get you through your assignment. There is a review on odd and even functions, so I'm going to do that real quick. So remember, I'll do all the axes in yellow. So an example of an odd function is one that has that, or let's start with evens. So an example of an even function is one that the y-axis is the axis of symmetry. So since I can fold this piece over to this piece perfectly just across the y-axis, this is going to be even. So even y-axis symmetry. Alright, odd. It's going to have double symmetry. So odd y-axis, then x-axis symmetry. It's actually called symmetric about the origin. It's like the math term for that. But what that is if I were to fold it across the y-axis and then fold it across the x-axis, it should line up. Okay? And then neither is just anything else. So if I have a parabola right here, it doesn't fold over onto itself across the y-axis. If I have a line that's right here, I can't use double symmetry or folding it across the y-axis. None of it works. So this is an example. These are a couple examples of neither. Okay? If you need additional help, please come to Math Lab. Until then, calculator.